Now we are at this question. Read this question. Another 90 minutes of non-stop mathematical problem solving. If three numbers A, B, C are selected from the series from first 15 natural numbers, there are 15 natural numbers 1, 2, 3, 5, 6, 7 and so on up to 15. Right? How many numbers are selected? 3 numbers are selected. 3 numbers are selected. What is the condition that needs to be satisfied by these 3 numbers? 3 numbers should be in arithmetic progression. 3 numbers should be in arithmetic progression. So if 3 numbers are in arithmetic progression, if A, B, C are in arithmetic progression, 2B is equivalent to A plus C. The middle term is nothing but the average of the first term plus last term, right? Average is nothing, right? Middle term is nothing but first term plus last term by 2. 2B equivalent to A plus C. 2B equivalent to A plus C. 2B is nothing but an even number. Even number is possible because of even plus even is even, or odd plus odd is also even. Even plus even is even, or odd plus odd is even. From 15 right natural numbers, there are 8 odd numbers. There are 8 odd numbers and 7 even numbers. 8 odd numbers and 7 even numbers. Out of 8 odd numbers, select any 2 odd numbers. Select any 2 odd numbers. Select any 2 odd numbers. Our condition is plus. From 7 even numbers, select any 2 even numbers. So 8C2 plus 7C2. Again I am explaining. Please don't count any cases. Don't do any counting. There are 15 natural numbers. In that 15 natural numbers, 3 numbers needs to be selected such that they are in arithmetic progression. If 3 numbers are in arithmetic progression, if A, B, C are in arithmetic progression, 2B is equivalent to A plus C. From where we derived, B is nothing but the middle value. Middle value is first term plus last term by 2. B is A plus C by 2. So 2B equivalent to A plus C. 2B is an even number. If the left hand side has to be even, it has to be even plus even or odd plus odd. Odd plus odd. In these 15 natural numbers, there will be 8 odd numbers. From 8 odd numbers, select any 2 odd numbers. If I select any 2 odd numbers, there will be only one way where they will be in ascending order. There will be only one way where they will be in descending order. So 8C2. From 7 even numbers, select any 2 even numbers. Any NC2 is nothing but n into n minus 1 by 2. So 8C2 is nothing but 8 into 8 minus 1 C by 2, which is 28. So which is nothing but 1 is 28, 7C2 is 21. 28 plus 21 is nothing but 49. Again I am explaining from where you got these 8C2. From 8 odd numbers, select any 2 odd numbers. Select any 2 odd numbers. If you select any 2 numbers, out of 5 natural numbers, select any 2, write 1 comma 5. Only one way it is in ascending order, 2 comma 5, it is in ascending order. Out of 8 odd numbers, select any 2. Or condition, so it is plus. Out of 7 odd even numbers, select any 2. It is 7C2. 8C2 plus 7C2, which is 28 plus 21. It is nothing but 49. Otherwise, what you will do is, you will unnecessarily count it. What we will do is, instead of 15 natural numbers, let us take first 5 natural numbers, so that we will check whether the counting and the answer, whether it is right or wrong. If it is first 5 natural numbers, if it is first 5 natural numbers, first 5 natural numbers are 1, 2, 3, 4 and 5. 2B is nothing but A plus C. It is an even number. So this will be even plus even, or it will be odd plus odd. Even plus even or odd plus odd. Out of these 5 numbers, 3 numbers are odd numbers, 3 numbers are odd numbers, 2 numbers are even numbers. 2 numbers are even numbers. Out of 3 odd numbers, select any 2, 3C2. Out of 2 even numbers, select any 2, 2C2. 3C2 is 3, 2C2 is 2. 3 plus 2 is nothing but 5. 3 plus 2 is nothing but 5. I hope it is clear. Why I am taking these first 5 natural numbers? Let us take it. 2B. Suppose the condition is A less than B less than C. Let us see with respect to counting whether you are getting any cases. 2B. If B value is 2, A value is 1, C value is 3. 2B, 2 2s are 4, 4 equivalent to 1 plus 3. This case is possible. If B is 3, 2 3s are 6, A is nothing but 5, C is nothing but 5. 2 into 3 is 6, 6 equivalent to 1 plus 5. Any other cases which we will get? 6. If A is 3, B is 3, A is nothing but 2, C is nothing but 4, 6 equivalent to 2 plus 4. This case it is possible. B is nothing but 4. If it is B is nothing but 3, any other cases are there? 1 plus 5, A less than B less than C. Okay, B is nothing but 4. So 8. 8 means 3 plus 5, it is 8. So that is also over. Any other cases? A should be less than 5. If B is nothing but 4, what is the other case that is present? 8 equivalent to 3 plus 5. If A is 4, A less than B less than C. No. B is nothing but 5. 2 into 5, 10. 10 means A value it is 4 and C value it will be 6. This case it is not possible. So any other case that is possible? If I take B value 4, A value it is 2. 2 4s are 8. C value it is 6. It is not possible. So which all cases we got it? Out of 3 numbers I selected any 2 odd numbers. Any 2 odd numbers I selected. So 3C1. 1 comma 3, 1 comma 5, 3 comma 5. That is clear. Okay, 2C2 is nothing but 1 here. So 3 plus 1, totally 4 cases we got. 2C2, we took it as 2, it is nothing but 1. I hope the idea is clear. Easily you can determine out of 3, select any 2. I selected 2 odd numbers. I selected 2 odd numbers, selected 2 odd numbers. 3 cases. Out of 2, select any 2. Only 1 case we got. So totally 4 cases we got, which is case number 1, which is case number 2, case number 3 and case number 4. This is exactly the problem. If you do counting, you have to keep checking the values. This will directly give you the answer. Counting means 1 case wrong, the answer will also be wrong. Answer will also be wrong. I hope it is clear. Next one. Instead of 15, one more question we will solve. 15. I took an odd number. Let us take a 50 natural numbers. If I take a 50 natural numbers and if I take the case A greater than B greater than C, A greater than B greater than C, 25 means there are 26 odd numbers. There are 26. Praveen, there are 26 odd numbers. There are 26 odd numbers and so here it is 50. Now what you will do is, we will erase it here. We took 50. Just give me 1 minute, sir. Pen is not writing. I am using. There are 50 means 1, 2, 3 and so on up to 50. So these 2 1s are 2 2, 2 24s are 48. So totally it is 24 even numbers I will get and 26 odd numbers I will get. A greater than B greater than C. Out of 24 even numbers, if I select any two even numbers, there will be in one way. Out of 26 odd numbers, select any two, it will be there in one way. Answer is 24C2 plus 26C2. I hope the idea it is clear. 24C2 plus 26C2. Very good question where you can use NCR here to avoid counting. Anyway, combination NCR is developed to avoid counting. Instead of writing the cases, this is the right direct way of writing how many ways are there. Next one, if the sides of a right angled triangle are in AP, first thing it is given that it is a right angled triangle. A right angled triangle is a triangle where one angle is 90 degrees. It is in 90 degrees. Sides are in arithmetic progression. If you are comfortable with Pythagorean triplet, if you observe 3, 4, 5, they are in arithmetic progression, right? If you get any other Pythagorean triplet, you do it. From this we can derive one good question, sir. Now there are some new terms which are there. What is this one? This is nothing but circumradius. R is nothing but circumradius. Circumradius is nothing but the radius of circumcircle. R is nothing but, right? R is nothing but, 1 minute. Here in this question, right? Here what I did it is, 1 minute, sir. 1 minute. Vishnu Sai is right. 50 natural numbers. In the 50 natural numbers, I don't know why I did 24, he is right. There are 25 even numbers and there are 25 odd numbers. 25 even numbers and 25 odd numbers. It is 25C2 plus 25C2, right? So it is nothing but 2 into 25C2. 2 into 25C2. Please note the correction. There is a calculation mistake in the previous question. There is a calculation mistake, right? Calculation mistake. These 25 even numbers are 25 odd numbers. So answer is 25C2 plus 25C2. Next one. It is R is a circumradius, so it is nothing but radius of circumcircle. Now what is a circumcircle? Right? Before we discuss the circumcircle, now please see here, point of intersection of perpendicular bisectors. Point of intersection of perpendicular bisectors is called circumcenter. Point of intersection of perpendicular bisectors is called circumcenter. Suppose if I take a triangle, right, take the midpoint of a side, take the midpoint of a side, take the midpoint of a side, drop a perpendicular. If I drop 3 perpendiculars, where the perpendicular bisectors will meet, perpendicular bisector, take the midpoint of a side, drop a perpendicular, take the midpoint of a side, drop a perpendicular, take the midpoint of a side, drop a perpendicular, right? Now see here, if I drop it, this is nothing but the circumcenter. The circle drawn by taking these circumcenter, right? The circle drawn, I will draw it again. Circumcenter. What is a circumcenter? Circumcenter is nothing but point of intersection of perpendicular bisectors. Point of intersection of perpendicular bisectors. Extremely important 2 or 3 key points are there which we will discuss. What is a perpendicular bisector? Take a triangle, take the midpoint of a side, right? Take the midpoint of a side. So it is D, and it is E, and it is F. Bisector means which divides the side into two equal parts. BD equivalent to DC, AF equivalent to FC, and EA equivalent to EB. It is bisector. Drop a perpendicular, drop a perpendicular, drop a perpendicular. If I drop a perpendicular from the bisecting point, there will be a point where it will meet, and that point is nothing but the circumcenter. That point is nothing but the circumcenter. Circumcenter is where three perpendicular bisectors dropped from the bisecting point intersect. Take a circumcenter and draw a circle. And draw a circle. A circumcenter, you will get a center of this circle, and the name of the circle is circumcircle. The name of the circle is circumcircle. A circumcircle is a circle which touches all the vertices of a triangle. A circumcircle is a circle which touches all the vertices of a triangle. Any circle that touches all the vertices of a triangle is called the circumcircle. The radius of the circumcircle is called the circumradius. Radius of the circumcircle is called the circumradius. Radius of the circumcircle is called the circumradius. Extremely important point. Two important key points are there. R is nothing but the circumradius, radius of the circumcircle. How you got the circumcircle? Take the midpoint of a side, drop three perpendiculars, join three perpendiculars, right? You will get a point. That point is circumcenter. From that point, draw a circle. The circle which touches all the vertices of a triangle is called the circumcircle. I hope it is clear. Now, based upon this one, now let us see. If I take a right angled triangle, one angle is 90 degrees. 100 plus questions I am going to discuss only on a right angle triangle. So, if you see, this is nothing but, right, if I take a midpoint of a side and drop a perpendicular and draw a circle. If I draw a circle, this circle is nothing but the circumcircle. This circle is nothing but the circumcircle. Now, if you observe, this is the bisecting point. Now, if you observe here, this is the center. This is the center point. Praveen, this is the center point. This is nothing but the circumcenter. Now, if you observe, this is the center. Center to any point on the circle, it is radius. Center to any point on the circle, it is the radius. Center to any point on the circle, it is the radius. Now, if you observe, AC is nothing but the hypotenuse. AC is nothing but hypotenuse. AC is nothing but hypotenuse. So, answer is nothing but circumradius is nothing but half of the hypotenuse. Circumradius is nothing but half of the hypotenuse. In which case it is true? It is only in case of a right angled triangle. Only in case of a right angled triangle, circumradius is nothing but half of the hypotenuse. Circumradius is nothing but half of the hypotenuse. Now, if you observe here, from here to here it is also R. This is nothing but the midpoint of a side. From the midpoint to opposite vertex, the line from a midpoint of a side, line from the midpoint of a side to an opposite vertex, line from a midpoint of a side to an opposite vertex, it is also called the median. Now, if I call this point as a D, median, BD is also the median. Median is also nothing but circumradius. Medium is also nothing but circumradius. In a right angled triangle, circumradius is also nothing but the median. Circumradius is nothing but half of the hypotenuse. Please make a note of this point. In geometric centers, I will discuss in detail what if it is an acute angled triangle, what if it is an obtuse angled triangle, because there is a new jargon that is there, capital R. Capital R is the radius of the circumcircle. Circumcircle is formed by drawing a circle by taking the center, which is formed because of the point of intersection of perpendicular bisectors. I hope the idea it is clear. So R, what is the next key point that is there? R, small r. Small r is the in radius. Small r is the in radius. What is this in radius? It is nothing but the radius of in circle. It is nothing but the radius of in circle. Then what is this in circle? It is the circle. Suppose there is an triangle ABC. ABC. Some angle A is there. Some angle A is there. Drop a line which will divide this angle into two equal parts, A by 2, A by 2. Drop a line which will divide it into two equal parts, B by 2, B by 2. Drop a line which will divide it into two equal parts, C by 2, C by 2. Right? This is nothing but AD, BE and CF. AD is nothing but the angular bisector. Bisector means anything which divides into two equal parts. Here it is dividing angle into two equal parts. Similarly, BE is dividing angle B into two equal parts. CF is the angular bisector which is dividing it, AD, BE and CF. Now if you see the point of intersection of angular bisectors, the point of intersection of angular bisectors, right, is nothing but the in center. It is nothing but the in center. Point of intersection of angular bisectors, it is nothing but the in center. Taking these in center, if I draw a circle, I will get a circle like this. Now if you observe, this is not the circle which is touching the vertices of a triangle. This is the circle which is touching the sides of a triangle. So in circle is a circle. In circle is a circle which touches all the sides of a triangle. In circle is a circle which touches all the sides of a triangle. I hope you got a clarity between circumcircle and incircle. Circumcircle is a circle which touches all the vertices of a triangle. Incircle is a circle which touches all the sides of a triangle. If he is asking you to find the radius of the circle which is touching the vertices, then you have to find circumradius. If he is asking you to find the radius of a circle which is touching all the sides, then it is in radius. I hope it is clear. But here the question is for a specific triangle, that is a right angled triangle. So in a right angled triangle, so right angled triangle will be like this, ABC. This is nothing but the in circle. Here it is, this is nothing but the in radius. This is nothing but the in radius. This is nothing but small r. This is nothing but small r. Total it is nothing but A. So here it is nothing but A minus r. Tangents drawn from an external point are always equal, A minus r. So here it is nothing but B minus of A minus r. Why? Because opposite to capital B is small b. So it is nothing but small C minus r, because total is nothing but this value is also nothing but B minus of A minus r is nothing but C minus r. b minus a plus r is nothing but c minus r. 2r is nothing but c minus b plus a. 2r is nothing but a plus b plus c by 2 minus b. I hope it is clear. 2r r. We will put it to the right side. This is nothing but extremely important. R is nothing but semi-perimeter minus hypotenuse. In a right-angled triangle, in radius is nothing but semi-perimeter minus hypotenuse. In a right-angled triangle, in radius is nothing but semi-perimeter minus hypotenuse. How you got these? Semi-perimeter minus hypotenuse. Second time I am explaining. Suppose there is a right-angled triangle like this. This is A, this is B, this is C. Opposite to capital B is the side small b. Opposite to capital A, it is small a. Opposite to capital C, it is small c. This is nothing but the in circle. This is the in radius. So from here to here R. Total it is A. So this will be A minus R. Tangents drawn from an external point are always equal. So here it is A minus R. This will be A minus R. Here it is R. This will be C minus R. If it is C minus R, this also should be C minus R. A minus R remaining is B minus of A minus R. What is the property that I used? Tangents drawn from an external point. Tangents drawn from an external point are always equal. Tangents drawn from an external point are always equal. Tangents drawn from an external point are always equal. These is nothing but the semi-perimeter, these is nothing but the hypotenuse. Now another important key point, we will understand R by R is always greater than or equivalent to 2. Please make a note of it. Right? R by R is always greater than or equivalent to 2. So ratio of circumradius to in radius, the value will be 2 in the case of an equilateral triangle. In the case of an equilateral triangle, ratio of circumradius to in radius will be 2. For other non-equilateral triangles, R by R will be greater than 2. R by R will be greater than 2. Another important key point, the distance between circumcenter and incenter. The distance between circumcenter and incenter. Distance between circumcenter and incenter is given by R into R minus 2R will give you D square. R into R minus 2R will give you D square. Right? What is this one? This is the distance between circumcenter and incenter. D square will always be greater than or equivalent to 0. Circumradius will be greater than or equivalent to 0. So R minus 2R will be greater than or equivalent to 0. R is greater than or equivalent to 2R. R by R is always greater than or equivalent to 2. Always. All these important key points are required for you to understand all the right, how to solve this question. Now the question is very easy. 3, 4, 5. 3, 4, 5. This is 3, 4, 5. Because the sides of a right angled triangle are in AP, it is 3, 4, 5. R is nothing but half of hypotenuse, which is 2.5. Small r is semi-perimeter minus hypotenuse. 3 plus 4 plus 5 by 2 minus 5, which is nothing but 12 by 2, 6 minus 5, 1. So R by R value is nothing but 2.5. In a non-equilateral triangle, ratio of circumradius to an in radius will always be greater than 2. I hope it is clear. In a non-equilateral triangle, very easy. Only thing here is 3, 4, 5, that value needs to be substituted because you can take any sides of any right angle triangle which is in AP. Now, another question. What is the sum of the first 10 terms common to the series? Now, this is nothing but an original cat question. This is an original cat question with elimination of higher values. Now see, what is this one? This is nothing but 17, 21, 17, 21, 25, 29 and so on. These is nothing but, right, every time there is a difference of 4. Every time there is a difference of 4. Next one, 16, 21, 26, 31 and so on. Every time there is a difference of 5. Every time there is a difference of 5. I need to get the series common to above series. Series common to. Let me call these series as S1 and S2. Series common to S1 and S2. Series common to S1 and S2. Series common to S1 and S2 is first term common. First term common. First term common. I need first term common plus LCM of D1 comma D2 into K. LCM of D1 D2 into K, because here it is going with a difference of 4. Suppose if I take some numbers which are going at a difference of 2. There are some numbers which are going at a difference of 3. This is the series with a difference of 3. This is the series with a difference of 9, 11, 13 with a difference of 2. The first term common is nothing but 1. What is the next term common, which is nothing but 7? 7 is nothing but the LCM of D1 it is 2, D2, D3 it is 3. Like that you will get the pattern. First term common is 21. D1 it is nothing but 4. Next it is nothing but 5. 21 plus LCM of 4 comma 5 into K. Sum of the first 10 terms. First term is nothing but K equivalent to 0, which is nothing but 21. K, because it is starting with 0, 10th term will be K equivalent to 9, which is nothing but 21 plus 29s are 180, which is 201. So Sn is nothing but n by 2 into first term plus last term. N by 2 into first term plus last term, which is nothing but 10 by 2 into 21 plus 201. You will get this answer. This is a very, very high frequency model that is coming in various management examination. What you need to do is, first you need to pick the first term common. First you need to pick the first term common. Then you need to take the LCM of the common difference. These difference is 4, these difference is 5. So answer is first term common plus LCM of D1 D2 into K. First term common plus D1 D2 into K. I hope it is clear. First 10 terms common. First term is K equivalent to 0. 10th term is K equivalent to n. And sum of n terms is given by n by 2 into first term plus last term.